The effects of scale factor on perimeter and area of similar figures. We know that similar figures are created when an original figure is multiplied by a scale factor. Scale factor is something that we have already talked about and practiced, so let's quickly review that. A figure multiplied by a scale factor greater than 1 causes all dimensions to get larger than the original figure. A figure multiplied by a scale factor between 0 and 1 causes all dimensions to get smaller than the original figure. A figure multiplied by scale factor of 1 causes all dimensions to remain exactly the same as the original figure. Scale factor is found by writing a ratio of corresponding side lengths of similar figures. More specifically, we know that ratio to be as k is equal to the new side length over the original side length. So now let's add another layer of learning to this idea of scale factor. Let's explore how scale factor affects perimeter and area of similar figures. How do we describe the effects on perimeter and area given a scale factor? To answer this question, let's begin by looking at this unit square. It has dimensions that are 1 unit by 1 unit. To calculate the perimeter of this square, we would add up all of the side lengths. 1 unit plus 1 unit plus 1 unit plus 1 unit is a distance of 4 units all the way around. To calculate the area of this square, we would take a side length and square it, or we can say 1 unit times 1 unit equals 1 unit squared, and this would represent the measure of the space inside of the square. Here we have a basic rectangle, which we will call rectangle R. Rectangle R has dimensions that are 2 units by 3 units. Before we apply a scale factor to rectangle R to produce a similar rectangle, let's calculate its perimeter first. The perimeter of rectangle R can be found by adding all of the side lengths. So we can say 2 units plus 3 units plus 2 units plus 3 units is a distance of 10 units around the figure. Now the big question becomes, if we apply a scale factor of 2 to rectangle R, how will this scale factor affect or impact the new perimeter of rectangle R prime? Let's model this effect by applying the scale factor of 2 to rectangle R. Because the scale factor of 2 is an amount that is greater than 1, we know that we're going to create an enlargement. So we're going to multiply the scale factor of 2 to each dimension in the original rectangle R, and that is going to produce a new rectangle R prime. So I'm going to take every dimension and I'm going to multiply it by the scale factor of 2. And when I do that, I know that I'm going to create an enlarged figure. So now here is our enlarged figure, and we're going to call this rectangle R prime. We know that this new rectangle R prime is twice the size of the original figure rectangle R because we applied a scale factor of 2. So that means that our dimensions for rectangle R prime are going to be 4 and 4 units by 6 units. Now let's calculate the perimeter. The perimeter of rectangle R prime can be calculated by adding up all of the side lengths. So we can say 4 units plus 6 units plus 4 units plus 6 units, which is a distance of 20 units. So now, how can we describe the effects on the new perimeter given the scale factor of 2? Now let's go ahead and examine it. The perimeter of the original rectangle R was 10 units, and the perimeter of the new rectangle R prime is 20 units. So what did you notice? After we applied a scale factor of 2 to all of the dimensions in the original rectangle R, we know that the new figure doubled in size. In other words, it got 2 times bigger. Did this hold true to the perimeter as well? Well, yes, it did. It also got 2 times bigger. It went from 10 units to 20 units because we applied a scale factor of 2. So, we can conclude that since the perimeter is only a one-dimensional measurement, we can multiply the scale factor to the perimeter of the original figure to find the perimeter of the new figure. And here is the way that your notation should look like. So we're going to say the perimeter of the new figure is found by taking the perimeter of the original figure and multiplying it by the scale factor. So make sure that you copy this down in your notebook, just the way that you see it. Now, let's see how the scale factor of 2 impacted or affected the area of the new image. To do this, let's calculate the areas of both the original rectangle R and the new image rectangle R prime. The area of the original rectangle R is found by multiplying the length times the width. So we would multiply 2 units by 3 units. That means that the original rectangle R has an area of 6 units squared. Now let's calculate the area of the new image. So we would say 4 units times 6 units. The new image rectangle R prime has an area of 24 units squared. So let's analyze how this scale factor of 2 affected the area of the new image. We can ask, well, how many times larger is the new area than the original area of 6 units squared? Is it 2 times larger, like when we calculated the perimeter? Well, no, because if we multiply the 6 units times the scale factor of 2, that does not give us 24. So, So maybe if we ask, how many times does the original area of 6 units squared actually fit into the new area of 24 units squared? So let me see. If we look at the model, it looks like if I divide this in half again, it looks like we can draw 4 sets of the 2 by 3 original figure inside of the area of the new figure. So we can say 2 by 3, and it looks like we fit 4 sets of it. 1, 2, 3, 4. So this makes the new area 4 times the original area. But why is it 4 times larger if our scale factor was 2? Well, here's the reason. Because area is 2-dimensional, 1, 2, the length and the width, the scale factor needs to be applied both to the length and the width. This means that we would need to take the original area of 6 units squared and multiply it by the scale factor squared. So in other words, we actually took the 6 units squared, and I'm going to take this off, and we multiplied it by the scale factor squared. This is why it is 4 times larger, because 2 squared is equal to 4. This is 4 times larger than the original area. And here's how we write this notation. So we're going to say the area of the new can be found by taking the area of the original and multiplying it by the scale factor squared. Make sure that you copy this one down too. Please copy down this cleaner version the way that you see it.